Students, good evening. Today I am going to solve a simple problem to enhance the experience of entropy change with the temperature. The problem comes under the category of entropy change with temperature. The problem is estimate the change in entropy if 5 kg of water at a temperature of 350 degree Kelvin is mixed adiabatically with 20 kg of water at 250 degree Kelvin. Assume that the specific heat capacity of water is 4.2 kilojoules per kg degree Kelvin. 5 kg of water at a temperature of 350 degree Kelvin. 20 kg of water at a temperature of 250 degree Kelvin. They are mixed together in a adiabatic reactor. Adiabatic means there is no exchange of heat with the surroundings. Clear? Right. The hot temperature gets cooled down. The cold water, hot water gets cooled down. The cold water gets heated up. This is a spontaneous process. The high temperature water decreases its temperature. The low temperature water increases its temperature. The new temperature, this is a spontaneous process. If you are allowed enough time, a new temperature will be arrived. The new temperature is called as intermediate temperature. Intermediate temperature. Now we can represent this intermediate temperature by notation T. Before solving this problem, I am going to find the intermediate temperature by using the known equation mCp dt is equal to mCp dt. This is for hot fluid, this is for cold fluid. Clear? For hot fluid, mass of water is 5 kg. 5 kg. Into heat capacity is 4.2 kilojoules per kg degree Kelvin, and difference in temperature. Initial temperature is 350, final temperature is intermediate temperature. So T minus 350 degree Kelvin. Clear? Again, the cold side, mass of water is 20 kg. Mass of water is 20 kg. Specific heat 4.2 kilojoules per kg degree Kelvin. The intermediate temperature 250 is the initial temperature, intermediate temperature T is the final temperature. So final minus initial, hence T minus 250. T minus 350, T minus 250. Multiplying with each other, 5 4.2 into T. Similarly 5 4.2 into 350. Clear? 5 into 4.2 into T minus 5 into 4.2 into 350. Similarly, 20 into 4.2 into T minus of 20 into 4.2 into 250. On balancing this equation, the intermediate temperature T is found to be 275 degree Kelvin. Now the intermediate temperature was established. Again I am going to find the value of changes in entropy. Clear? Changes in entropy. The second law of thermodynamics, the mathematical representation of second law of thermodynamics is dq by T. dq by T. Integral dq by T T1 to T2. Clear? Right. What about this? Instead of dq, I am going to substitute C dt. C dt. So del S is equal to, because ds is equal to dq by T. This dq is C into dt in terms of heat capacity. This expression is explained in terms of heat capacity because hot fluid rejects certain amount of heat, cold fluid receives certain amount of heat. Hot fluid rejects certain amount of heat, it depends upon its heat capacity. Cold fluid receives certain amount of heat, it is also depends on its heat capacity. So I am going to write this equation in terms of heat capacities. So C into 1 by T into dt. So 4.2 into ln final temperature T2 to T1. Clear? Del S. This is for hot fluid. Similarly for cold fluid. The temperature change alone gets different. For hot fluid, for hot fluid, then is equal to 4.2 into ln. Which one is initial temperature? 350 is the initial temperature, that is T1. Which one is the final temperature? Intermediate temperature is the final temperature. So 275. Clear? What is the answer? Minus 5.0083. What is the answer? Kilojoules per mole. Kilojoules per kg. Kilojoules per kg. Okay. For cold fluid, changes in entropy 4.2 into ln. What about the final temperature? What about the initial temperature? 250. Final temperature 275. What is the answer?
8.006.
8.006 kilojoules per kg. Right. The total entropy change, total entropy change is equal to entropy change for hot fluid plus entropy change for cold fluid. So minus 5.083 kilojoules per kg plus 8.006 kilojoules per kg. The answer becomes, what is the answer?
2.923
kilojoules per kg. This is the answer. For every 1 kg of water, 2.923 kilojoules of entropy gets changed. This is entropy change with respect to temperature. Thank you.